something that I care very much about. My name is Lukas. I'm going to give you like a very, very brief introduction about what I do and what my department does, and then I'm going to tell you something about that we started developing along, I would say, like half a year or something. That was like an amazing journey for us to really improve what we're actually doing as data scientists in our organization. Before I start off like telling you what we actually build, I'm just setting the scene a little so you guys can understand why we started building something like that. So I'm located in the data analytics department at Mercedes-Benz. We specifically focus on the area of finance. And we had this before today that a lot of finance use cases might not be very interesting, and maybe from a data science perspective, this is to some extent true, right? Because I didn't study finance, I don't have like an education in controlling or accounting, but nonetheless, these are numbers, and finance itself is like basically at the heart of finance is always just numbers, right? So this is somewhat where I feel comfortable with data science. We are a little department, I would say, that was founded in 2016, and by now we have a team of like 35 people, and my colleague Timo, who also was a lot of different teams, right? We have different functions like data science, data engineering, and we all work together to help basically our organization. There are a lot of things that we're doing. Most of them surround somehow forecasting, analyzing, or predicting how our finance or how business is going to change. And we do this by supporting the business with a lot of forecasts for financial KPIs that we're doing. At the beginning of this, we were basically using typical time series methods, right? I mean, everyone basically knows these kind of forecasts, which you produce with univariate models. This is what you do, not only because, or this is what we did, not only because we didn't know like how to do anything else, but it's really tough to get data sometimes, right, in organizations. And I'm pretty sure that you guys can relate, right? Getting all the data that you need is basically the hardest job at the beginning. So what we did at the beginning was a lot of univariate forecasting. This is, of course, very boring to data scientists, right? So with time, we improved our data infrastructure, and we got to do some multivariate forecasting, which obviously is still not the end of it, but at least it's getting somewhere, right? It's getting somewhere kind of exciting. And what happened then was, instead of like going further, developing fancy models, fancy deep learning models or whatsoever, we started to say, okay, let's wait a second. All that we're doing basically here, this is kind of a no-brainer, right? Building forecasting models is somewhat, I would say, very repetitive. And so what we started, instead of trying to build fancier models and better forecasting or machine-based forecasting is actually very nice. So what we did was we started with automated forecasting. We were looking at basically all that we're doing, and it was basically the same thing all over and over and again, right? So what we did was we were looking at our process, the data science process itself, our workflow, and we were looking at tasks that we can automate. And this is something that a lot of people have done before. I mean, there's a lot of pretty cool stuff out there. Probably most of you guys know Data Robot or H2O, and I mean, obviously also Google has some features, Dataiku has features with this. But something that we needed didn't really fit with all of these products. What we really need is we need some kind of like a very generic time series forecasting tool. All of our time series are somewhat different, right? Most of them get reported on a monthly basis, a daily basis, weekly basis, but still they have very different patterns simply because they represent different parts of our business. And this is why we needed to have something very, very generic, however, very related to like business seasons, right? That meant that we needed to be able to have a product that is very flexible when it comes to forecasting, simply because different departments have different KPIs that they plan and need to consider, and they have different kind of horizons they're looking at. We have departments that need to know 15 months in advance what their KPI is going to look like, simply because they make contracts with that. We have other people or other departments. They don't need to know that 15 months in advance. It's like 2 days before the month they want to know the closing value. So we needed to be very adaptable and flexible with the horizon of the forecast that we built. The next point is If you look at controlling or accounting, a lot of KPIs are based on other KPIs again, right? So you have somewhat a hierarchical tree that you can represent with machine learning. And this is something we wanted to definitely integrate, because within the structure or within the components in each KPI, we actually got a lot of information. So we needed to have some kind of way to implement hierarchical forecasting into a product like this. The next thing is you guys cannot imagine how often a forecast or a plan or even a normal figure that has been reported is being changed, simply because you get effects from controlling that actually that happened today, but they affect like a booking or a KPI a couple of months back. So this is something that we needed to have very, very flexible. The next part is that obviously explainability of AI or explainability of our machine learning models is extremely important. So we sort of needed to find a way to have our own explainability concept that is really important to our business people. We needed to put it in there somehow. And obviously the next part is around the programming of itself, right? The programming of the software that we did. And that was obviously something that we just wanted to do because it's really fun, right? I mean, what are you doing? Like, if you're a data scientist, then you obviously want to code, so we also wanted to do that. And what we essentially programmed was we looked at the entire process that we're going through with the data that we're getting. Obviously, at the beginning, I mean, all of you know that the data preprocessing is very important simply because the data that you have in systems is extremely messy. And most of the times, and we had a speakers dinner yesterday and we talked about this. At Mercedes-Benz, we have roughly 7,000 registered data systems. And from these 7,000 systems, we're drawing data to build models, right? And you might think, oh my, this are probably totally different systems, but they're not. Sometimes they even overlap. Some of them are SQL-based, others are text-based. You have basically every kind of data storage technology. You probably find it in every large organization, right? So the data preprocessing part is very extensive and very important to this. The next part is, and this is very specific to our business case, this was one of the factors why we started building something ourselves. The kind of feature engineering that we do is very related to our business and very related to like the business seasons that we're having. So that's why we build, based on the business knowledge that we kind of gathered, we think at least, we build like a set of very generic functions that can represent that kind of business trends or business-based transformations that we need to do with the data. The next part is the feature selection. This is something all the data scientists know, right? Obviously, there are a lot of different like feature selection techniques vary quite a lot from the field I'm trying to apply to. Whether I'm in NLP or in like structured data, then obviously it changes quite a lot how I need to do the feature selection. So we were really sitting down and trying to boil down on the perfect way to select features just for time series. So this is purely based on time series, what we're doing, and if you want to read on this, there's also an open source package that we published for this. But what we really needed to do is we needed to have like a credible feature selection for time series. The next part is that we selected a class of like 10 different machine learning models. Obviously, there's no deep learning in there simply because everyone knows if you look at finance data from organizations, you have like, if you're very happy, you have like 100 data points, right? So we're not talking about anything related to big data here, but everything that we're doing in the finance area is more or less small data. And obviously people might think, oh, this is not cool if it's not big data, but that makes everything actually much more difficult if you have small data. And this is also why we needed to like handpick a couple of model classes that could handle small data. And these are mainly very penalized models that we needed to deploy here. What we did was, I know a lot of people are now going to say, why is it not in Python? Why is it in R? Or why is it not in Scala or Go or C++ or whatever? You have a lot of different ways to program something. I have to agree, sometimes I prefer Python, but there's one specific thing in R that Python does not replicate, at least I feel that way. The grade is the generic data manipulation, generic data preparation. This is done very, very well in R. There's a lot of packages in the entire tidyverse, it's called, around dplyr and so on, that are very specific to this. It's very easy to build like a very generic data preparation pipeline in R. What we did was we basically looked at this data generation pipeline or data manipulation pipeline, and we sort of changed it, and we sort of built something around this so that we can now build an automatic machine learning pipeline, quite fitting to the R interface that people like. The next part is that I know people might think that R is not an object-oriented programming language, but you actually can program quite object-oriented in R, and this is what we did here as well. And that makes it very accessible. I know you guys can probably not see this well, but you have to believe me that you can very easily access all the information in those objects. And this makes everything quite neat and also easy to get all the information that you need. The next part is, I know this graph doesn't look so nice, but at least you can read it now. I think this is a plus. We integrated hierarchical forecasting in that. And the good thing is, since we built this kind of more generic package, it's very, very easily applicable to any kind of hierarchical structure that you have. So you basically generate an object, which is the outcome of an automatic machine learning pipeline, and you can seamlessly pipe that into an entire system or entire hierarchical tree system. And this is what is making our life a little easier. Something that was very funny there is that when we presented this to our managers, they were like, oh, this is great, so please redo everything you did before. And we did that, and it turned out that I'm not much of a better data scientist than the code that we produced. But that's also okay, right? I think I think it was Sean before who was saying something that you need to automate yourself out of existence, right? And this is kind of very true, because we did this, and now instead of building kind of boring prediction models for a time series, I'm actually trying to wrap my hand around how to scale this in an enterprise. The first thing, obviously, is we publish the entire source code in our Daimler internal Git, so that all employees of Daimler can actually look at the source code. This is obviously for some reason that we want to get their feedback on this, but also because we want to start this kind of open source culture. And in a big organization, open source is not really like the hippest thing, so I'm not sure that there was a lot of other content before on our internal GitHub now, but this is something very nice. The next part is, and this is something that R manages very well, you can very easily build everything you do in R into an API, and this is also what we did. So now we can provide this entire machine learning capacity as an API, so that means that you can also access it from Python or R or Java, whatever. You just need to know how to access the API, and that is basically a no. And why I'm here today at this conference, you can actually use Dataiku to do this. You can actually distribute your knowledge and your packages and whatever using Dataiku. There's one thing that you can do is you can just upload the code. So it's basically a function on Dataiku that everyone can use. And this is quite nice, right? So all my other data scientists, they can now start using the package that we built simply in Dataiku, and this makes it very easy. Right? So they don't need to install anything, they can just use it. The next part, and now this is where it really comes in that what I like a lot about this Dataiku platform that we install or that we're having is you can, I'm not sure whether you guys did this before, but you can actually build plugins, right? Dataiku's strong suit, so to say, is that they allow a lot of data manipulation and a lot of modeling without using any code. This is obviously very attractive to business users. What we can do as data scientists is we write something cool, we program something cool, and then we can put this into like a visual recipe. So people don't have to code, but they can use the entire software that we produced. And this is exactly what we did. So we put basically our code in the backend of a recipe, and now people can very easily just basically select what they want to do. They can select the number of models, they can select the size of the grid they want to test without any kind of code, and now they can use it. And the funny thing about this is that this is making our life very easy. Obviously, we could have built a very fancy application, and just because we like it, we're also going to do that. But using Dataiku is making things very easy, right? I can have an integrated patch management. I can just update the entire plugin for everyone whenever I want to, right? Things are not going to, there are not many dependencies that I cannot handle. So everything that people are doing with this is kind of in my control, in the sense that when something is going wrong, I can immediately fix it. I don't have a very complicated distributed system or whatever. I have a central place where my plugin is stored, I can edit it, and now everyone can use the functionalities that we programmed. Obviously, we're not at the end of this yet, so as I said before, we want to build a fancy application simply because that's, I mean, also kind of interesting and cool. But what is really nice about this is that there are a lot of technical features in there that are not very relevant for the business. They're actually not relevant at all, but they're very nice for us as data scientists. For instance, one thing is that we already managed that it's quite easy to push all the forecasting jobs to a cluster, right? So this is making things very efficient. So this entire pipeline is running extremely fast, even on a local computer. The next point is that Dataiku just allowed us to basically build web apps within a plugin. So I can basically build an entire fancy application inside a plugin and then deliver it to people. So I don't need to take care about the hosting. It's very nice. Obviously, we're also going to add some kind of more features, more modeling and whatsoever, but in its essence, really, we're at a point where people can actually benefit from something we built. And it's not just a simple use case or whatever. It's more or less like a generic enablement tool. And obviously, we can improve some things, but this is something that is really exciting, right? Because we're giving what we built on all the information that we have, on all the knowledge, we're basically just building it and giving it to people so they can use it. Obviously, they might not do all the coolest things with this, but at least I can share my knowledge, and this is something very great. So that was about the talk. Thank you very much, and have a good day. Thank you.